All right, so like I said, 9.3 exponential functions. So they start out in this section getting you familiar with the little e in mathematics. This little e is called Euler's number. And it's a constant like pi. So remember, pi goes on forever and ever, 3.14, blah, blah, blah. Well, Euler's number does the same thing. So it's a never-ending decimal. So I'm going to go to the calculator and show you how to find it on your calculator. So let me share my calculator. So there's two places for E on your calculator. The first, if you'll look above the division symbol, you see a little blue E. So if you hit the second button and the division button, it pulls up the little E. And I'm going to hit enter to show you it is a value around 2.12 if you rounded it up. But y'all, this thing goes on forever and ever. So they're going to have examples where you're going to estimate the value of E and then E to different exponents. So say I'm going to do E squared. If I want to use E with exponents, on the left side to the left of the 4, you see a LN button. Okay, so that's a little L and N. We'll learn about that one later. But above it is a little E with an X to it. So if you'll hit the blue button and then that LN button, it pulls up the little E flashing for the exponent. So then I said E squared I was going to look at. So if I put in my 2 for my exponent, I hit enter, it gives me the value. So I wanted y'all to see where the E was on your calculator, because some of these examples, they're going to have you approximate the value of different E. So let me go back to my pad. And remember, E was approximately around 2.72. Now, these examples are going to want me to round 4 decimal places. So y'all, I'm going to refresh y'all on rounding. So if I had something like 1.12345, let me let one in real quick. So when you round off, remember, the first number after the decimal point, that's the tenths. T-E-N-T-H. Where the 2 is, would be the hundredths. The 3 would be the thousandths. And the 4 would be the 10,000ths. So the first one I got before the decimal, that's the ones place, and then you'd have your tens, hundreds, and so what to the left side. But on the right side of the decimal, it starts with the tenths, then the hundredths, thousandths, 10,000ths. 5 would be where they would have the 100,000ths and so on. Now, remember, if they want me to round 4 decimal places, I go to the 4th number. So to round to the 4th decimal place, it depends on what that 5th number is. So remember, if it's 5, 6, 7, 8, or 9, you round to 4 up. If that would be a 0, 1, 2, 3, or 4, you would leave the 4 the same. So if I was rounding this one to the nearest 4th decimal place, I would have to turn that 4 into a 5 because of the number after it. So just remember all that from the past. So the first one wants me to use a calculator to approximate the exponential expression to 4 decimal places. All right, so I'm just going to set my calculator out here so I don't got to keep flipping back and forth. So y'all, the expression they're giving us for number 1 is e to the 3rd. Now, these crooked equal signs, those mean you're approximating. Because remember, these are never-ending decimals, so we are only what we call approximating the answers when we round them off. So we're rounding this one off to 4 decimal places. So since I got an exponent on my calculator, I'm going to hit the second LN button to get the E with the exponent. Put in my exponent of 3 and hit enter. So notice I'm getting 20.08553692. So I'm just putting everything that was on my calculator screen. Now they want us to round this 4 decimal places. So the 4th decimal place would be to, let's see, 0855. So the second 5 is in the 4th decimal place. So it depends on that next number, which is the 3, to determine how I'm going to round this off. So let me bring down my 20.085. All right, this place with a 5. After it is a 3, so that's less than 5. So I do not round up. So that 5 will stay a 5 for that answer. And that's what I would put into my math lab. So y'all, I'm going to get my chat ready. So I want y'all to approximate this one. Some of y'all should have a calculator. So approximate this one though. Watch this, how they word it. Approximate to the nearest 10,000ths. Well, remember the 10,000ths, that's 1, 2, 3. The 10,000ths is in the 4th decimal position. So that means it's still doing the 4th decimal position. They're just calling it the 10,000ths this time. So most of these exercises are going to have you round 4 decimal places, whether they call it the 10,000ths or whether they say it like in that number 1. So y'all are giving us e to the negative 3.45. All right, so second LN to get the E, that was what, a negative 3.45. So we hit enter. So we get 0.0317 456 364. So I'm going to let y'all chat that one out and see what you get, rounding that to the nearest 10,000ths. So let me pull my chat up. Okay, so I've already got an answer. So let's see if that's right. 0.0317. So the 10,000ths was the 7. 4 is less than 5. So good job. That would definitely 0.0317. So, y'all, that's how they're going to start out, giving you a few examples just to sort of play with the E and see what kind of values you get out of it. And then they want to make sure you can round off those answers. Because when you're messing with the E, we'll see it later on in life for sure when we do the interest type problems. That's what E plays a lot of roles in interest problems when you're looking at continuous compounding. And we'll sort of learn about that later, okay? So now they wanted us to look at graphing exponential functions. So we're going to be graphing exponential functions. So these will come in the form of y equals a to the x. Notice the variable is now the exponent in these problems. A is what we call the base. It's the number being affected by whatever these exponents are as I go out my domain, okay? Now, for this section, it's really important that you recall any number to the 0 power. Do y'all remember what any number to the 0 power equals? Well, that could be 2 to the 0, 3 to the 0, x to the 0. But what does anything to the 0 power equal? All right, y'all, so let's see. Let's play a 2 in here. 2 exponent 0. Guess what? When I hit enter, calculator gives me a 1. 3 exponent 0. When I hit enter, calculator gives me a 1. X exponent 0. Hit enter, calculator gives me 1. So y'all, any number to the 0 exponent equals 1. Okay, so we're going to play with some of these graphs and see what they look like. So the first thing I'm going to do is I'm going to graph y equals 2 to the x. So for this problem, my base is 2, and I'm going to be changing these exponents to see what my y variables will equal. All right, so let me get me a little graph going. Now, y'all won't have to draw these graphs and stuff for the first part of this section. You just got to choose A, B, C, or D on the graph they got. Okay, so I'm going to start out picking 0 for my x. So y'all, if I put a 0 in for the x, y equals 2 to the 0, what's my y value going to be? So good job, it's going to be 1. Remember, so that means all these exponential graphs, no matter what the base is, they're going to go through that point 0, 1, which is right here on that y-axis. So that's one property about exponential functions is they're all going to cross that point, okay? So now if I put a 1 in there, 2 to the first power would be 2. So when x is 1, my y value is 2. Now watch this, when my x is 2, so I put a 2 in for the x. So what is 2 squared going to give us? Oh, let me, oh, no. Okay, I see it now, 4. Remember, 2 squared would be 2 times 2, which gave me 4. So when it's 2, I'm up here at 4. And let's do one more on that side. How about a 3? So what is 2 to the third power equal? So remember, that's going to be 2 times 2 times 2. And what y'all got? 8 is good. Good job. So at 3, this thing's up here at 8. So see, it starts doubling. Those y values start doubling. this is what the COVID graphs look like. If you ever watched them on TV, on the news, after a week, it doubled from 1 to 2. Next week, it doubled to 4. Then it doubles to 8. That's what they're talking about on that doubling rate. Now, let me do a negative exponent. So this would be like 2 to the negative 1. Now, to make an exponent positive in math, we place it under a 1 and change the exponent to a positive. So anytime you got a negative exponent, put it under a 1 and change the sign. And then 1/2 to the first is just 1/2. So notice on the negative side, it's at 1/2. So barely about a half in between 0 and 1 on the y's. And I'm going to do one more. If I put a -2 in for that, 2 to the -2, remember, make the exponent positive by putting it under a 1. So I get 1/2 squared, which will give me 1/4. Now y'all check this out. On the calculator, 2 to the exponent -2. If you do it on the calculator, hit enter. It's going to give you a decimal. But remember, hit math and enter twice. It'll turn it into a 1/4. So the calculator don't mind those negative exponents. So over here at -2, I'm way down here at 1/4, barely above the x-axis. But notice on the left side, it sort of comes down and tries to get to the x-axis, but it never can touch the x-axis. On the right side, it's going to start shooting up towards positive infinity. As these exponents get bigger and bigger, this value will just keep getting more steep, okay? Notice on the left side, negative exponents make the number smaller than 1, so it just keeps trying to get to that x-axis. So y'all, y = 2 to the x. Let's go to the calculator and I'll show you how to graph that. So I would go to my y =, I would put in my 2 and then hit this under the clear button. The upside down V is what we call a caret for exponents. So hit that and then put in your x value. So now y = 2 to the x. If we graph it, whoops, let me change my window back to a normal window. So zoom 6. That'll get me back to a 10 by 10. So there we go. Looks just like what we draw. The left side trying to get to the x-axis, right side heading up to infinity. And if we look at our table by hitting second graph, look at it. These y values are doubling at 1 to 2 to 4, 8, 16, 32, 64. On the left side, on those negative x's, notice how they are getting smaller and smaller as we get out to the negative side. Okay, so they're getting closer to 0. Can't really hit that 0, so that's why they sort of make a horizontal asymptote on that side. But y'all, what's nice in this section, we got our calculator and it'll graph all these for us. So now let me show you what happens when we graph a fraction. How about y = 1/3 to the x. So these graphs will be similar yet different, okay? So I'll just go out about 5 on this one. All right, so let me put that down. All right, so I'm gonna make another table up. Now, for MathLab, you're just gonna pick an ABCD picture, so y'all can just go straight to the calculator and graph these, and then choose a picture. Now, if you do this one on the calculator, you better put that fraction inside parentheses before you do the exponent, okay? All right, so let me start with 0. So what would 1/3 to the 0 exponent give me? Oh, y'all know that. Anything to the 0 equals 1. Good job. So this one will pass through 0, 1. Okay, so 1 on the y-axis again. Now, if I put a 1 in here, 1/3 to the first power is 1/3. So anything to an exponent of 1 is itself. Now, if I put a 2 in here, I would have 1/3 squared. So square the top and square the bottom. So 1 squared is 1 times 1 is 1. 3 times 3 on the bottom gives me a 9. So notice when you got fractions here for your base, the y values are getting smaller and smaller as they go to the right. So at 1, I was at 1/3. At 2, I was at 1/9. Next, it would be at 1/27, 1/81. They're getting smaller and smaller as you go to the right, trying to get to the x-axis. So let's see what happens with these negative exponents. So if I had 1/3 to the negative first. So when you got exponents raised to a when you got fractions raised to a negative exponents, you flip the fraction and make the exponent positive. So regular numbers like 2 to negative exponents, we put under a 1. It's like we're flipping it, and the bottom's a 1 on those. Here, you flip the fraction, and this is basically 3 divided by 1 is 3. So 3 to the first power would be 3. So over here at -1, it's up here at 3. And then at -2, you would have 1/3 to the -2. Since that's a fraction, flip it. Get 3 over 1 squared. Oh, I think you already got me an answer on there. It looks like y'all got a 9. But that's going to give me a 9. Good job. So at -2, woo, I'm way up here at 9. But you see what happens on a fraction? It reverses the graph. When it's a number to an exponent like we had up here, when the base is a number greater than 1, it increases left to right. When it's a fraction, which is less than 1, it decreases left to right. So on those first few problems, you won't have to graph them. They'll have pictures for you to choose out of, okay? All right, so let me move my back up here. All righty. So now, this part you will have to do in Math Lab, and I'm going to show you how to graph in Math Lab for these parts. But now we're going to look at our translations. Like we did back in 8.1, we're going to move the graphs up and down, left and right. So remember, we're looking at graphs of y equals a to the x. These are my exponential graphs. A is the base, remember? X is the exponent. So the first translation is a vertical shift. So the graph of y equals a to the x plus or minus b. So they're just adding or subtracting a number at the end of the function. If it's positive b, it's going to go up. If it's negative b, it's going to go down. So the same exact moves it was in 8-1 for the vertical shift. Adding or subtracting a number increases it or decreases, okay? Second shift is a horizontal shift. These will be left or right. So y equals a to the x plus or minus c. Now y'all notice the difference. Vertical shifts, it's not in the exponent. You bring it down and then you add or subtract a number. For a horizontal shift, you're actually adding and subtracting from the exponent. So remember, if it's a positive c, this will move left. If it's a negative c, then it'll move right. So when you attack the x, just like we did back in section 8-1, if you add to the x, it goes left. If you subtract from the x, it goes right. So that one's sort of backwards still, like it was then. The third one is a reflection over the y-axis. Now remember, back in 8-1, if we put a negative in front of the a, that reflected it over the x-axis. So to reflect it over the y-axis, you'll have y equals a to the negative x. So now if you make the exponent negative, it reflects it over the y-axis, okay? Alrighty, so let me pull up MathLab and see what it has for these problems. So these will start out, let me find them. All right, y'all, so those are the ones we just did where you're just picking out the different graphs. All right, so this one has f of x equals 2 to the x plus 4. So remember, they're attacking the x up in the exponential part of this problem. They're adding 4 to the x. So remember, when you add or subtract from the x, it's a horizontal shift. So what do y'all think they want me to move this one, left or right? They're adding 4. So we're definitely going to go left 4. Now notice on this problem, it says, hey, start with the graph of y equals blank. So let's see, A was the one that moved it left. So what you got to put in here is the base we had. So since ours was a base 2, in that egg, in the box, you have to put 2. So we're starting with the graph of y equals 2 to the x, and then we're going to shift it 4 units to the left. And then all you're doing is checking the answer. Now they're going to want us to graph this. So y'all, here's how you graph these. You're going to click the enlarge the graph. The tool you're going to use is the second row, the second one. It says exponential tool. You click on that and then click anywhere on the graph. Once I click on the graph, it's going to draw the basic exponential graph. Remember, we got to use these buttons down here to move it left or right. So that one was left 4. So I would take the horizontal shift and go left to negative 4. And see, it's moving it for me. Now, y'all, here's where people mess up. You see in the very bottom left of that box I just used, it has a base down there. By default, it's got the little E down here. You got to change that E into the base that we had in this problem, which was a 2. So down there, you got to tell it, hey, I got a base 2 for this problem. Then when you save it and check your answer, it'll give you the correct answer. If you leave that as an E and forget to change it, it will mark it wrong. Although the graphs look similar, the values are actually a little bit off on them, okay? All right, so let's look at another one of these. Look here, sketch the graph of f of x equals 2 to the x minus 2. So that minus 2 is not up there with that x. So y'all, what do y'all think that minus 2 is going to do to my graph? So let me get my chat box back up. So I'm seeing a down 2, looks good to me, right? Down 2. So when it hits the x, it matches left to right, but this is at the end. So we would click to enlarge the graph, click the exponential tool, the little uphill looking curve, and then click on the graph. It puts it in the middle. So let's see, down 2 would be vertical, go to -2. All right, so are we done with that? No, good job. Look down here, it's got that E again for my base. And see, what was my base on this one? It was a 2 again. So make sure you put a 2 in for that base. And then you save it and you check your answers and you move on. So some of them, we got to tell them to move. Some of them, they will have just the graph on them. So y'all look at this one. Oh, it's the same problem, ain't it? Describe how this graph can be attained from the basic graph. Oh, hold on. This is the finishing of my first. Okay, I didn't see this with the finish of it. So start with y equals, this one has 2 to the x. Be careful you don't put the one that says 2 times x. So start with 2 to the x, and then, oh, what'd you do? You move me down 2. So then shift down 2 units. So I guess this one just had me graph it first, then describe the moves. All right, so this one's a little tricky. So let's sketch the graph first, and then I guess we'll do the moves. So I'm going to go in order on this. So first, we're going to grab our tool we need, and we're going to click on the graph. All right. First, that 2 is positive. So since that's 2 is positive, it's going to move me left 2 units. So I would go to my horizontal and go left 2. That x is negative, so that's going to reflect across to y. Okay, so mine's good to go now. So I got -2, reflect across to y. My base is a 2. So the only other thing is that +3 at the end. What's that +3 doing to us? So y'all, the +3 is doing what? All right, so how was I? Keep clicking that box in it. Let me start over on my graph. All right, so -2 on horizontal. Reflect across the y. And then you said up 3, so let's go up 3. All right, the base is a 2 on that one, so we would save that. And be done with it, okay? I bet this will have the second part will be telling us to describe it. So there you go. So we started with 2 to the x, we went left 2, reflected across the y, shifted it up 3. So that's our A on that one. So that one they had all ready for A. And then you go to the next question. So I do my moves in the order that I come to them. So the 2 was first as the exponent, then my negative x, and then that 3 at the end. All right, so let me skip that. And that's basically doing the same. Well, I'll graph it. So my base on this one is a 2. That 1 at the front, you could treat it like it was at the back. This could be like a -2 to the negative x plus 1. They just got it out of order. So treat the 1 like it's at the back. So let me see what all we got. So we start with the graph of y equals -2. Since the exponent is negative, it's going to reflect me across the y-axis, right? Also remember, we're going to go up 1 unit. So let's see. So the only one that goes up is A. Because remember that negative in front of the 2 is going to reflect me over the x-axis, okay? So I'm getting reflected over the x because of the -2. I'm getting reflected on the y because of the negative x. And then that 1 would be like it was at the end and it's positive. So you always start with the graph of 2 to the x. Click that. It's going to then have us graph it. So we're going to click on the graph. All right, so I need to move this so I can see real quick what my problem was. All right, so click the graph of the exponential tool, click anywhere on the graph. So we reflected on the y. We reflected on the x. We went up 1 unit, so that would be vertical, up 1. And remember, the most important part, change that base down there from an E to a 2 for this one. Remember, you don't have to put the negative in there because the negative got taken care of on that reflection over the x, okay? So y'all need to save that and see it's got the graph all flipped and raise it up 1. All right, y'all, so chat's open. So y'all, we're going to start with the graph of y equals what to the x. I'm going to let y'all answer. So what would y'all put in that first box? Y equals blank to the x. So your base is 2, so I'm going to put a 2 in there. All right, then it says shift it blank 3 units. Well, the 3 is being added to that exponent x. So is that going to go left, down, up, or right? So left, so we would come down and click left, good job. And then blank 4 units. So that being a -4, what's that doing? So it's going to go down 4, good job. All right, let's see. It's going to say check answer. I wonder if it's going to make us graph it. Let's see. So then it wants you to graph it. So click graph. Grab the exponential tool. Well, let me move this where I can see it a little bit. All right, grab that exponential tool. Click on the graph anywhere. So the 3 y'all said went left. So that'd be horizontal left 3. Then y'all went down 4, so vertical would go down 4. And remember, click where the base is and change that from a E to a 2 for this problem. And then y'all, you would just save it and move on. So these moves are very similar to the moves we did. Okay, so let me go back to my pad now. To the moves we did back in 8-1, okay? All right, so for the end of this, we're going to learn a formula. A of t equals p to the 1 plus r over n, all raised to the n exponent of n times t. This is the formula to find how much money is in an account after t years. So t is for time. P is your principal. Your principal balance or your starting amount. So basically the principal is the starting amount. Okay. R is the interest rate. And the interest rate has to be in decimal form. N is the compounds. That's the number of times a year they apply interest to that problem, okay? So they'll use words like quarterly, which is the four times, right? They'll do semi-annual, which will be twice. Monthly would be 12. Yearly would be once, and so on, okay? So let's see. Now, A is the amount in the account. The amount in account after T years. So if I did T of 5, that would tell me the amount in my account in 5 years, since T is in years. So time we're looking at in years, okay? Now, let me recall y'all on finding percents, okay? So remember, if I had something like, how about 25%? Well, we can't put 25% in the formula. We got to change this to a decimal. So remember, to change a percent to a decimal, you move the decimal, which technically is after the 5. You would move that decimal left twice, and let's see. Exactly, you're going to get a 0.25, okay? Good job. So how about 5%? So what would y'all get for 5% if I'm changing it to a decimal? So good job, 0.05. So you still got to move it left twice, which means in this case, I had to add a 0, okay? All right, y'all, so let's see the examples they're going to hit us with for using this formula. So suppose $57,000 is invested at 5.5% interest, compounded quarterly. So for A, they want me to find the function for which the investment grows after T years. So they don't want me to really work it out for any certain times. They just want me to come up with the function that I would use to figure out those amounts. So some things we need, we know we're going to have a function that's sort of similar to this. And we're going to be putting in values for all of this, okay? So A of T would be the name of the function. And I think MATLAB actually gives you the A of T. You just got to figure out everything else going into it. So our principal is the amount we start with, $57,000. Then we have parentheses, 1 plus R divided by N. So we need to figure out R real quick. R is 5.5%. I'm going to change 5.5% into decimal instead of fraction. So remember, 5.5%, a half would be a 0.5. It's still in percent. So remember, change that fraction to a decimal. So 1 divided by 2 would give you 0.5. If it was a third, you'd get like 0.333 and so on. But remember, move that decimal left twice. So this would give me a 0.055. So that's my R. So I put in my 0.055. So let's see, it's compounded quarterly. So what would N equal if it's compounded quarterly? How many times would that be a year? Okay, so I see some 4s on there, so good job. So N would be 4. So where N was in the formula, I'm going to put a 4. And then it has an N also times T for the exponent. So that'll be 4 times T. So now, if we know what years are, we can put that in here and figure out the amount. Now, MATLAB wants you to figure out what this part equals before you put it in the answer blank. So we got 57,000. Because I guess MATLAB thinks, hey, follow order of operations and get me a number in here. So let's see what 1 plus 0.055 divided by 4. Let's see what that equals, and we'll replace that into parentheses. So that equals 1.01375, 1.01375, and then my exponent will still be 4 times T. This is what MATLAB wants. Although this is correct, it's not simplified enough for MATLAB, because MATLAB says, well, they can work that and get me a number out of it, okay? So now 57,000 times 1.01375 to the 4 times T. If I know what my T's are, I'll be able to get my values. So what would this, if T was 0, remember T would be 0, that's your starting amount. Well, 0 times 4 is 0. This to the 0 power would be 1. So 1 times 57,000 would give you 57,000, which is your actual starting amount, okay? So remember, at T0, you'll get your principal. Now, as I go through the years, these amounts will change. So let's see what they wanted for part B on this. On part B, they want to find the amount after T equals 0, 2, 5, and 10 years. So it looks like I got to put 4 numbers in for the t and see what amounts I get. So let me break them down over here. T equals 0, t equals 2. What was left? T equals 5. And t equals 10. So on the calculator, there's 2 ways to do it. One way is to put a 0 in for the t. So we got 57,000 parentheses 1 plus 0.055 divided by 4. Those parentheses, exponent 4 times 0. Now, I could have went to this formula too. I could have replaced 1 plus 0.055 over 4 with this decimal we got while going. We'll get the same answer. So at time 0, we better have what we started with, which was our 57,000. So at 0, you got 57,000. And y'all at 2, I'm going to use the simplified formula, 57,000. 1.01375, close parentheses. Exponent now, t equals 2 will be 4 times 2. So let's hit enter. And now these are wanting me to round to the nearest dollar. So the nearest dollar would be before the decimal. So that looks like what, a 63580. Since that's a 1 behind the 0, I don't round up. So that'll be 63580. And y'all, I would continue on doing that. Notice as time increases, that amount better increase, okay? If it goes smaller than what you started with, probably got a mistake there. Now, y'all watch this. I'm going to show you a way to get these 4 values even quicker. I'm going to go to y equals, and I'm going to clear that out. I'm going to put this function in y equals 57,000 parentheses 1.01375 close parentheses. Exponent will be 4. Now remember, on the calculator, instead of using a t, you got to use the x. Okay. So when you're graphing on it, you always want to change the variables to x's on it. So that's your basic graph. And I'll go to the graph. Now we're not going to be able to see it because my graph is only at 10 and this thing would be at 57,000. I just wanted to quit thinking over here with them dots. Now, watch this. If you hit second trace, because you want that calculation button, number 1 says value. I'm going to hit enter. So let me start with the first one, t equals 0. If you graph it and then you come in here and use that value button, watch this. X equals 0, if I hit enter, I get my 57,000. Watch this. Second trace value again. Let me put a 2 in for the X. So when time is 2 years, I hit enter. Well, there's my 63,480.186. Same thing we got while go. Hit second trace again. Value. Time is 5. So at 5, let's see what we get. Oh, so this one I would round up because that 1 point, it has a 7 after the decimal. So that's going to turn my 1 into a 2. So I get 74,902. So remember, round up. If you're going to the nearest dollar, that's before the decimal. Look at the cents. So that's like 79 cents, which would turn that dollar into 2, okay? Oh, and then finally, t was 10. So watch this. Second trace for my calculation for value. 10 in for my x. Hit enter. And that's a 0.9. So that's going to turn my 5 into a 6. So I get 98,426. See, all that's why I love my calculator. When I got stuff like this and they want me to find all these different values for the years, I put it in my y equals. Although I'm not going to see the graph, I can still use the value function for that graph, okay? All right, y'all, let's see. Let me flip my paper over. So I got one more to show you, and then that'll take us through your 9.3. And this is another example using that formula we just looked at. We're still looking at this. A of t equals p times 1 plus r over n raised to the n times t. So on Melissa's 6th birthday, she gets a $6,000 CD that earns 6% interest, compounded semi-annually. If the CD matures on her 16th birthday, how much money will be available? So a little girl gets a CD for $6,000 on her 6th birthday. It earns 6% interest, compounded semi-annually. So if the CD matures, that means it gets back 100% on her 16th birthday. How much money will be available? So we got to take our equation. So y'all, we got to figure out what is our t going to equal, or n, r equal, and our n equals. Because we're actually looking for an amount on this one. So what would the time be if she got it on her 6th birthday and it matured on her 16th birthday? So definitely it's going to be 16 years old minus the 6-year-old when she started it. So that gives us 10 years. So we're going to find the amount after 10 years. That's going to equal her principal, which was 6,000, times 1 plus. So let's see, they said 6% interest. What would that be in decimal form? All right, so that's going to be 0.06. So we got 0.06 compounded semi-annually. So what would n be? How many times a year are they compounding it when it is semi-annually? All right, 2 question mark. No, it's 2. Remember, semi-annual would be 2, quarterly 4, monthly 12, yearly 1. Okay. So that would be 2 for the n. So I put a 2 here. And I know my time, which is 10. So in place of the time, I put my t. So we got everything in the formula we need. So we're just going to go punch that on a calculator. And this one, they want me to round to the nearest cents. So that is 2 decimal places, okay? So we're going to round this one 2 decimal places. So we got 6,000, parentheses, 1 plus 0.06 divided by 2, close parentheses, exponent is 2 times 10. All right, remember the nearest cents, that's going to be 2 decimal places. So that's what you got to watch for also. The problem I did before, which is like 13 for y'all, you round to the nearest dollar. This one is to the nearest cents, so that's 0.66. You got to look at the 7 after the 6, which is 5 or greater. So since that's 5 or greater, that second 6 becomes a 7. So this looks like 10836.67. So look, the little girl got this on her 6th birthday. In 10 years, she now has $10,836. So I guess if she wanted a vehicle or something at her 16th birthday, that'd work. Or keep saving it and keep making money. So y'all, when you do this, when you better end up with more money than you started with, okay? All right, y'all, so let's see. That was it for that section. So remember, it's going to start out playing with the E a little bit, just for you to approximate it, 4 decimal places. Then you got your little bit of graphing. And then the translations like we did, left, right, up, down, reflecting. And then it ends up using the interest type problems, okay? Now, later in life, when we hit 9.7, we'll do interest problems that are what we call continuous compounding, and we'll see the little E in those problems, okay? So these are just compounded, regular compounding. All righty, so in y'all 9.3 that we just did does not have a support section for it. So the only assignment this week, other than knocking out your test, was 9.3, okay? So sort of like this week, but I like that because you can knock out that test 3, do the bonus, remember, send that back. I got yours, Kara, on the bonus. And y'all test 4 we'll knock out test 4 in the next 2 weeks coming up before Thanksgiving break. And then y'all got a whole week to catch up on everything. Hopefully we get back from Thanksgiving. We'll review for test 4, review for the final, and then y'all will be done with me, okay? So the final starts December 7th, which is a Wednesday, and it'll be due Sunday, December 11th. And remember, I replaced one low test with that final exam grade, and y'all gonna love the final because it's all multiple choice. Okay, so you don't have to try to figure out how to put the answers in Math Lab. You're just gonna click A, B, C, or D and move on. Claire, did you figure out that foiling problem? All righty, good job. All right, y'all. So any more questions out of y'all? All right, so y'all, good luck on test 2. Remember, it's not due this Sunday, but if you want to keep on course, try to have it due by Sunday, okay? Because it's a light week this week. And remember, if you got any problems, then email me, and I can usually answer y'all through an email if I got to. All right, y'all, let me stop my recording, and I'll get this thing out.